Welcome back. Today I carry on with my second video for the Turbine Interchange in Jacksonville, Florida. In the previous part, I started to put together the layout and the links and started to discuss how to deal with situations where there is an intersection um, very close. So let's just carry on doing the next bits. And so we are here. Since it is an exit, it is fine, so I don't worry about that split there. I mean, we could, but it doesn't look like it's a major one since it's a single lane exit. And there isn't, well, it's a weave on the, is it a weave on the other hand? No, it's not a weave. No, sorry, it's a two-lane exit with a weave, yeah. Well, I think I just leave it. If you have a huge number of vehicles exiting, you might need to add this exit here. It depends on basically the traffic volume you get from the service. Okay. Then we need to do this one here. So how many lanes do we have? It's 5. And for such connectors, I don't need to change the lane changing distance because it has no impact on it, since all of the lanes connect the connector. And just one idea, you might want to watch this video on a 1.5 or 2 times speed because it is a long one. Probably today it's going to be a long one as well. So sorry about that, but I don't want to speed up the recording in case someone wants to actually listen to what I say when I need to explain something. Okay. So I'm just putting together now the main line. We will look at the driving behavior settings as well at some point, but the problem with that is you are not supposed to change it unless you have a reason to do, and your reason would be validation calibration or calibration validation. And since we are not going to do that, that's not really applicable. I might show you where to change them and what to do. But I can't really justify any change I make since I'm not that I don't see how traffic operates. So I just do what I can basically. So here, okay. So it's another exit like that. So it's not very good for micro simulation to have two lane exits. So I'm going to show you here in this one what is the other way to model it in case you have issues. Issues, I mean too many lane choices and not realistic queuing. So what you can do in that case, you just basically create a 6-lane road here. Is it 6? It's 5. Sorry. So you basically create one like that. The reason I say this because if you have two, so for example, like here, this if you use dynamic assignment and even if you use static, you need to specify. If you use static, you need to specify the split between these two, which is not healthy. And if you use dynamic, the model will try to converge these, and that is fine. But if you have a congestion anywhere, that will lead to issues. So I told you when we modeled this that I will make some edge closures and stuff. So just keep tuned for that one. I will explain what I mean and how to deal with it, and you will see what's the difference between this and that. Okay, so we have a two-lane section going out. I'm going to just convert this one. So as you can see, the difference here, I do it differently by just using a two-lane exit, and this way I remove that route choice. And to be fair, it is perfectly fine like that. And you can justify it modeling it that way. Of course, it might be the case that some authorities or councils say that when they check it that they don't like that, but it might lead to a better and more realistic performance in many cases actually. So it is something to consider. Okay, that. And now here, so this is already after the section we agreed to do. Since it's incoming traffic, if you have data and the traffic volume is not negligible on this arm, I would do it this way. So I would model it. I would model that entrance or access and would extend this link so you can allow for lane changing. It's always a good idea in these situations to artificially increase the length. Maybe don't even follow the road, but just to increase it. Because it can help when you load vehicle to represent the actual lane changing maneuver, so they have time to get into lanes and for future cases, assuming that you have a big development that adds a lot of traffic, and that queue can be visualized and understood how far it extends and what it blocks back and what it doesn't block back. So I just add these two. I just add these two locations there. Okay. So what do we have here? There is a 3-lane widening somewhere. Well, it's amazing that I can't see anything. Okay, it is here probably. So I split that link here. I try to have a free lane. I try to have that extra lane as soon as vehicles can squeeze into it, plus a few meters. So when a vehicle comes here, it can squeeze in already here in a few, maybe 3, 4, 5 meters, and you can just add this extra for that. So I would allow this. So if a vehicle can get into this lane in a queuing situation, you should have that lane here in the model. Okay. Okay, I split it. It's gonna be a 2-lane link. It's gonna be a 1-lane link. That. Just like that. Okay. Where is that lane going? Is it still the same 2-lane? Yeah. Yep. I'm going to just use the generate spline tool again. So I just place a few intermediate points. So the software can calculate the curve. And it doesn't matter that much if you are a few, I don't know, feet off. It's not going to have an impact. Okay. I think that's perfectly fine. Okay. I'm going to do this tooling section here. Right. Setting up the connectors, and then we can just make that extension on it. I'm going to close this. So it's a two-lane exit. Okay. So here I'm going to follow. I'm going to follow my previous way of modeling this as a two-lane exit because it is faster for me to do so. But I think that just from the experience that works better, or in many cases it creates issues when it is not like that. So unfortunately it seems you have another weaving section. Weaving is when there is traffic going from this lane there and from traffic going from that lane there, or more accurately between these exits. So from that lane going out to the off ramp from the main line and from the on ramp going onto the main line. So they basically weave when you have the crossing. Okay, so here we will need to put that if you have traffic data, it is recommended to model. Yeah, I would model this at least as a loading point. Okay, so I will get back to there. Let's just see if there is anything left in the south. Yeah, so I think now, let me just extend this a little bit there. Since it's an exit, I'm not that worried about this exit there. For entries, it is more problematic usually. But again, if you have very um, complicated movements in and out, it's probably better to include even these. But you need to stop somewhere, So I would include these waves, but when it's an exit, if you don't see any issues coming back, and again here, there is not a lot going. You have a business park or something, but I don't see a lot of parking space. So there is just not a lot going on in this intersection that suggests, yeah, because that is access from there. This is more like yeah, there is much more parking here. So I would, yeah, there is a lot more parking there. So probably they access it through that one, that intersection. Of course, they can access it there as well. But if they go to the left, they might come this way. If you go to the right or to the east, they probably come through this one, but that is way out of our model extent. And this, again, this example video is about how to model this intersection or interchange. And I already explained why I would do it. And again, the good practice would be to include these since they are very close. And again, you will make the decision that if you want to spend time and you have the data to do so. But if not, you need to extend the links, especially the entry links, to show any queuing. And if you see queuing there, that that will make it even that will show even more that and prove and confirm that you need to add those. But when it's weaving again, I would model at least that. Yeah, okay, so let's do this. How many lanes do we have? Is it 3? Yeah, I think it's 3. All right. So, okay, it seems there is a lane gain somewhere because there is 2 lane here. So we need to have a look at that. Right. Okay. Let me just check where is that lane gain. It's here. I changed it to 3. I pull this a little bit back because I think there is already enough space for 2 vehicles here. Yeah. Yeah, something like this is fine. And even probably a little bit more than that. Realistically, I think that would make more sense. Okay. Right. Here, let's sort out the exit. Okay. Okay, let's just drag this. Just check that we have the same number of lanes here. It looks like 3. Is that a hard shoulder? It seems so. That just, yeah, for safety, just in the median. Okay. If I can't see something correctly here, just make a note in the comments, and I will correct it for the future ones. So what do we have here? So it is 1, 2, 3, 4, 5. So what we do is we basically cut this link and convert that into a 5-lane one so they can complete the merges. So let me just add 2 more lanes there. So let's just see. So it's the same 5 lanes. Okay, so when I think, how is the merge? So it's a single lane. It is so hard to see. It is a single lane coming up, I think. Yeah, it's starting here. So I'm not going to allow lane changes there. Yeah, I'm not. You could model it differently. So you could do it this way, or you can just start the lane here. Let me do it that way. Yeah. So when these are very close together, let's say here, what you can also do, I just don't like doing that. That's why I'm not that keen. So because it can cause bugs, and not real bugs, but very strange behavior. So the no lane change thing. Of course, I always mix up which one is which. So you can do it like that. And then again, this application depends on if you want to achieve something on these, because vehicle can see better each other. So you might need to use that, but I like never used it. But again, it's a American interchange. Vehicle might behave differently a bit, which I'm not aware of. So if you need, I just wanted to show you that this is a way also to model it. Just you need to be careful. So I did it for the exit, like the merge. But if it's a diverge, you need to consider this length in your emergency lane changing distance. So you need to add that. Otherwise, vehicle will stop here and try to change lanes, and they can't. Okay, so I have trouble seeing what's going on here. So I barely can make out. It seems to me that it's a four lane road. Yeah, 4-lane stretch. So 4. It had 5 lanes there. It has 4 lanes here. So somewhere here there is a lane opening. Okay, I'm going to model it with a 2-lane exit here as well. And let's just see what do we have. So we will have 3 lanes, 3, yeah? No, 4 because that's the exit. But that exit opens here, I think. So it's 3. That's the solid line there, if I'm right. If I'm not, sorry, but I just can't see what's going on. So make that as 3. Let's just see. So I think the problem is I can't see. So I assume that is similar to I can't find, where was it? Let's just see. Let me just check that again. It is 3 lanes. But I can't see. I think that's 2-lane. But is it just a single lane exit like in the UK they have? No, the vehicle drives there and drives there, and it feels that. Okay, I'm going to assume that I have 4 lanes there. There is a dedicated exit and a lane will open. So I will have a short 5-lane. I can't see how it goes. I mean, I could check the Google Earth, but a street view, but I'm not going to. I checked it on Google Maps yesterday, and this part is still under construction, so I'm not going to worry about it. So yeah, I don't want to dwell much more on it. How many lanes? It's 4 lanes. Not this one. This one. Okay. So the lane opens there. Okay, I'm going to do it differently. So the way I will do it is this. I will do it like it is. It is like here. Again, I can't see what's going on, so I just assume that there is a segregated turn. Okay. Okay. Um, sorry if it is not the way it is real time. Oh, sorry, on the street, but I can't make out how it is. I just can't see. If you have a good screenshot or something, I'm happy to update. So I assumed a same one as here. We are extend. I'm not going to model this move, this interaction. That is just off. Um, okay, let me do that. I just really don't want a 2 hour long video. I'm doing the same stuff. So we have that. There is still some roadworks going on. So where this goes. Okay. It seems that this is still under construction. So what I do, I just basically assume it as a 2 lane stretch, and that's it. I can't do more. I can't see what's going on. I think it will be soon refreshed, probably the aerial foot view. So it seems that the 2 lane is segregated all the way well in advance. Yeah, I mean, it seems there's a lot of traffic going on here. So, I mean, you can model it. But I'm not going to. I will just assume that traffic is loaded separately. I think when you model the turbine intersection or interchange, your job is not to model the movement in that interchange. I just assume that we already have that data separated out, so it will be a separate zone. Okay, I just connect these up. All right. Then where this one comes from, it comes from here. So this becomes a 4 lane somewhere here. Yeah, somewhere here. We will need to review the lane changing distances. So just I'm not forgetting them, or I don't forget them, hopefully. But I will do it in one go. like that. Seems it is coned off. What is it? Is it a lane? It is coned off. Okay, I'm not going to dwell on it. It is just a 3-lane road. If you know better, please model it the way it is. I just can't see from this footage what it is. Okay, now they join together. Yeah, it is much clearer here with the asphalt. Okay. Okay, so we are going to have this one, this slip road or ramp, as you would call it. Okay. So I merge these back. I add the lane. We can join these two together. And I already see there is some issue there. Looks quite funny. Okay, so I just extend this a bit. Again, since it seems there is a weaving, you might want to model this. So like come up here and just split it into two. Like it is here just the other way around. Okay, so I think the links are in place. If I did not miss something. So now what we do? What we do is I just switch that off. I switch off the section. I visualize the lane changing distance. So what we want is we want to make sure that so it is set up there, it is set up here. It is an exit, so it doesn't matter there. Um, Here it matters. So here, well, we could model it as a 2-lane exit. I mean, yeah, I did it this way. If it works funny, if you do it this way, then change it to a 2-lane exit, like I did in some other place, like that. Yeah, like this, for example. And so here you want to add a little bit more than 200. What you want is at least, well, the best is if you check the the signage where you have the signed gantries, and according to that, and just use the same for this one, just a little bit extra, since it's maybe 30 meters more. And also in the new Vissims now you can use this distribution. You can go even more detailed. So here you want to have more than 200 again. And 500-600 is usually a safe bet at least. But on busy motorways you want at least like 2 kilometers, 3 kilometers, like 1-2 miles even. Usually you have at least a mile, some signs, and even before that, maybe. So here this section is 133. So 200 here is fine. You need to make sure that in these cases, this connector, the lane changing distance is more than the length of this. So you don't have vehicles going out and then coming back in. Okay. Then here, this is fine. It is fine. You don't need anything. Here, you again want to increase this 500 maybe. So this one is 533 long, so that's fine. So vehicle can get, and also you want to do, so you want to make sure that this one uh, is as long as this. So you might want to increase this to 550. And so in that case, you won't have someone from that lane going out and then coming back in. Okay. You don't need lane changing distance there. Here, you don't need anything because that's a lane gain. What you want to do here is, this is 618, so I would put it to 650. Again, to avoid overtaking on the outside lane, the curbside lane. And here you can put at least 600 in it again, or even more. And that's fine. Here you don't need, usually this is 96, so 200 is fine on these. And it's not even need, yeah, you don't want vehicles again to come out here and then back. Here 400, I think it's fine. Or maybe less a bit. Well, because you can actually drive here. If you come in, you probably start looking to change lanes earlier. Here you don't. Well, for this one, it doesn't really make sense to increase it further because you can come in earlier. Mhm. Okay, here there is nothing. So for these, probably you want more. You want at least 400-500 again. Again, best is if you check the signs, and then you can just use those signs. And here I have already set it up. Yeah. So I think, okay, here you can increase it a bit. Yeah, so here it's interesting because you can add a very long lane changing distance. So to only get out here and there, but this one is 364, so you want to have it as long as this because we will add an edge closure, so we will close the edges, so it can't happen that someone comes in this lane and then goes out there. So I will lock this only goes there and that only goes there. I know in real life it can happen that they go like that, but in the model you don't want that. You will end up with a huge issue. Of course, if you see that many people do that, then of course you need to consider, but as a default, I'm not going to. Okay, why is it 300? Yeah, yeah, because they will start changing lanes. So I think that's it for today. Next time, I forgot some lane changing distance, but when we run the model, we will see. So next time, I will carry on setting up conflict areas, speeds, things like that. So I hope you find it useful or you found it useful. Let me know in the comments if you have anything. Um, so yeah, thanks for watching. And I know it was a long one, but for some people it might be what they are after. Thanks.